Okay, in this screencast we're going to look at some trig identities as promised in the title, including the double angle results. Very exciting stuff. So this is really for the purists, for the diehards. We're getting into some serious theory here, and I know most of you, if not all of you, will absolutely lap it up and love it. So right, let's get started. What we need to get going here is this. Right, we're all happy and familiar with our little unit circle, aren't we? So, and we also have established that the equation of this circle is x squared plus y squared equals 1. Can't believe you haven't seen that before, but there you go. It's the equation of a circle, just like y equals 2x plus 1 is the equation of a line, just like y equals x squared is the equation of a parabola. X squared plus y squared equals 1 is the equation of the circle centre of the origin, radius 1. Right, that's enough on that. We also know, don't we, that x can be written as cos theta and y can be written as sine theta. So therefore we can write this as cos squared theta plus sine squared theta equals 1. That's a massive result, and one we use a lot, and will underpin some stuff we're going to do. We're going to develop now. Okay, so moving forward from there, I might use my same little circle here just to establish my first little double angle result. Okay, so if I drop a vertical down there, which that will be because this angle in here is theta, as is that, making this whole angle here 2 theta. Right, so what we're going to investigate is this green length here. This green length. Now that length, we'll call that AB. Okay, and this can be O. So AB, the length AB is what we're going to investigate now. So let's have a look at that. Well, what do we know about AB? Well, we know that this part of AB here is the y distance, is it not? So it will be the y coordinate at A. That length there will be equal to the y coordinate at A, and the y coordinate at A is equal to sine theta. So that's equal to sine theta, as is that. So the whole length AB is equal to 2 sine theta. Make sense? Hopefully it does. So that's AB, right? Well, that's great. There's not a lot to go on at the moment. We haven't really broken any new ground there. But what we're going to do now is find another way. Let's find another way of working out what AB is, and let's bring out some old trigonometry here. We've got an angle at the centre here, which is 2 theta, and we know this is the unit circle, isn't it? So that's 1. That's 1. If we want AB, isn't there this little thing called a cosine rule? AB squared equals 1 squared plus 1 squared minus twice 1 cos 2 theta. Oh, look at that, a double angle. As promised, a little double angle result is about to appear. So AB squared equals this. Let's just do a little bit of work on that. That's 2 minus 2 cos 2 theta. That's AB squared. Alright, we want AB, so let's just bring this back. Therefore, AB is equal to the square root of this. I don't need to consider the negative of it, do I? Because AB is a length. Now, let's step back and take a little look at this. I've got a result there for AB. I've got a result there for AB. It's the same length. So would it be fair to say, therefore, that 2 sine theta is equal to the square root of 2 minus 2 cos 2 theta? I reckon it would. Now, what we want to do here is do a little bit of make cos 2 theta the subject, so we've got a double angle result. This one here, a double angle result. Right, we want to know what cos 2 theta is. So let's get the subject to be cos 2 theta. You guessed it, we're going to have to square both sides firstly, aren't we? So it's 4 sine squared theta is equal to 2 minus 2 cos 2 theta. Just changing that over to this side. we get 2 cos 2 theta equals 2 minus 4 sine squared theta. Dividing through by 2, we get cos 2 theta is equal to 1 minus 2 sine squared theta. Magic. That's a double angle result for cos 2 theta. Okay, we're going to rack up some results here, so let's keep going. Sine squared theta. Right now, I said we're going to use this. I said we were going to use it, and we are. From this nice little result here, we can make cos squared theta the subject and get 1 minus sine squared theta, and we can do the same for sine squared theta to get 1 minus cos squared theta. Alright, that's nice. We'll wrap all this up at the end, so don't get too stressed about it. Let's just follow the development. I'm going to write that sine squared theta now as 1 minus cos squared theta. So I'm going to say that this is equal to 1 minus 2 bracket 1 minus cos squared theta, which is equal to 1 minus 2 plus 2 cos squared theta, which equals minus 1, so 2 cos squared theta minus 1. Okay, that's another result for cos 2 theta. So at the moment we've got this as a result for cos 2 theta, and we've got this as a result for cos 2 theta. That's cos 2 theta there. It's equal to both those things, just one in terms of sine squared, one in terms of cos squared. And we're going to come up with one more, and this one's going to use the fact that 1 is equal to sine squared theta plus cos squared theta. Right, so we're going to bounce that down here, and so we're going to get another result that says sine squared theta plus cos squared theta minus 2 sine squared theta. So we've got cos squared theta minus sine squared theta, and there is our third cos 2 theta result. Prolific little fella, cos 2 theta is equal to 1 minus 2 sine squared theta is equal to 2 cos squared theta minus 1, and they're all equal to each other, equals cos squared minus sine squared. Wonderful. Okay, so lots happening there. That's cos 2 theta. We want a double angle result for sine 2 theta. Naturally. What are we up to? 7.5 minutes. Keep going. Okay, so from cos 2 theta equals 1 minus 2 sine squared theta, we're going to drag from this result here. We're going to pick him up, and we're going to write him as, okay, I tell you what, we're going to square both sides. This is not going to be particularly obvious at the moment, but I want to get sine 2 theta result. So squaring both sides there, squaring both sides, I get cos squared 2 theta equals 1 minus 2 sine squared theta squared, which equals 1 minus 4 sine squared theta plus 4 sine 4 theta. Okay, that's cos squared 2 theta. I'm running cos squared 2 theta now. Beg your pardon, cos squared 2 theta as 1 minus sine squared 2 theta, making lots of errors. Sine squared 2 theta, I'm probably rushing a little bit. Okay, where did I get that from? Cos squared theta equals, got it from here, 1 minus sine squared theta. So replace theta with 2 theta, and we've got this result down here. 1 minus, I'm writing that as that, and there's my double angle. You see, that's why I did that. So that's the same thing, 1 minus 4 sine squared theta plus 4 sine to the power of 4 theta. This is brilliant stuff, isn't it? I knew you'd like this. Right, I'm going to make sine squared theta now the subject, so sine squared theta, 2 theta again, sorry, sine squared 2 theta equals, right, now let's just get this right, that's now come over this side, 1 minus 1, the 1's are gone. I've got the 4 sine squared theta over here, and I've got minus 4 sine power 4 theta, sine squared 2 theta. Therefore, if I now, if I just, that's equal to, I can take out 4 sine squared theta, and in brackets I've got 1 minus sine squared theta, and that, as we all know, is 1 minus sine squared theta is cos squared theta. So now what I've got is sine squared 2 theta equals, excuse me, equal to 4 sine squared cos squared theta. So my final statement is therefore taking the square root of both sides, sine 2 theta equals 2 sine theta cos theta. Massive result. There's my double angle result for sine. Sine 2 theta equals 2 sine theta cos theta. It's 11 minutes now. So all we've developed there, I'm going to start up another YouTube for some examples, but all we've done here is develop some results for the double angle results for sine theta and cos 2 theta and sine 2 theta. It developed out of initially recognizing that the unit circle has equation cos squared theta plus sine squared theta equals 1. And there's a couple that peel off that, just making sine squared theta and cos squared theta the subject, no big deal there. We then went to develop AB and the distance AB, and we wrote it down in terms of 2 sine theta, just using what we know about the coordinates of A, the y coordinate of A specifically. And then the cosine rule. This is the cosine rule here, and in green, these green statements, these that I've framed in green, they're both AB. So then I just made those two equal to each other, and I went and squared both sides. I got cos 2 theta equals this, and then I just fiddled around. Look at this. Changed sine squared to 1 minus cos squared, got another result. I changed 1 to sine squared plus cos squared, and I got this result. So in 3 highlighted results for cos 2 theta, and to get sine 2 theta, I took this result here at the top, squared both sides, and did some really attractive algebra on that, and pulled it right back to get sine 2 theta as a result there. Now in reality, what you need is what I've highlighted, and so you're not going to need to prove these, but I'm not going to insult your intelligence and just give you results without developing them for you. So I'm going to close this YouTube. I'm going to open up a new one and work through some examples, see how this stuff's used, and hopefully your brains haven't exploded. I'll see you soon.